Hi students, how are you? I hope you are fine, my dear students. So listen students, in the last class we discussed about force and balanced force and unbalanced force, internal force and external force, and definition of force and effects of force. What are the effects of force, my dear students? So force can change the condition of motion. So the condition of motion will be possible in three ways. The condition of motion will happen in three ways. The first is force can move the object which is at rest. We can say it is accelerated. So because when the body starts moving from the rest, we can say it is accelerated. What is acceleration, my students? Acceleration you have learnt in the previous class, in the previous chapter, motion. Change in velocity is known as acceleration. So when the object is at rest, whenever it moves from the rest, there is a change in speed. That's why we can say it is accelerated. It is the first effect of force. The second effect is, we can force can increase or decrease the condition of motion. We can simply say force can stop the moving object. So which means whenever the object is in motion, it has certain velocity. So whenever the force is applied on it, so the velocity will decrease. There is a change in velocity. Change in velocity we can say acceleration. So the second is what? So force can change the speed of the object. Force can change the condition of the velocity. So it is also known as the object is accelerated. The third is force can change the direction of a moving body which is moving in a straight line. So if a body is moving in a straight line, if you apply the force on that body, it will turn in different direction. So the change in direction of the velocity is also known as acceleration. So in the third case also it is accelerated. So again I am repeating, my students, force can cause there are three effects of force. The first is by using force, so the resting object will move. It is known as accelerated. The body is accelerated. The second is the body which is in motion already. So if you apply force on the body, its velocity will increase or decrease. So the change in velocity, increase or decrease velocity, we can say accelerated. In the third, so if the body is moving in a straight line, so if you apply force on the body, so the body will turn. There is a change in direction. It is also known as accelerated. That's why force is defined as. So in the previous lecture, in the previous video, I defined force as force is an agent which changes the condition of motion. Which changes the condition of motion. Condition of motion will be in three ways. Those condition of motion I told you earlier just now. In three ways. Resting object will move, moving object will increase or decrease the speed, and then a moving straight line object will turn. That is simply we can say, if you apply force, the body will accelerate. That's why the definition of, we can define the force. Force is an agent which causes the acceleration in the body which is being applied on the body. The force is being applied on the body. So force is defined as, force is the agent which creates the acceleration in the body. So is known as force. So the effects of force and the force. So we can see by one experiment, students. Let us see that experiment.
Effects of force. Force produces effects on shape, motion, direction and speed. Effect on shape. Take a balloon filled with air and press it. Its shape changes. A metal rod bends on being given a few hammer blows. From this, we can understand that force can make a change in shape. Effect on motion. A force can make a body move and can stop a moving body. For example, when we kick a football, it moves through the ground but when we catch it, it stops its motion. Effect on direction. A hockey player strikes the running ball to change its direction. From this, we can understand that a force can change the direction of a moving body. Effect on speed. A force can also change the speed of a moving body. For example, when you're pedaling a bicycle, if someone pushes you from behind or pulls you back, speed of the cycle changes.
So students, after learning these force and effects of force and balanced force and unbalanced force and internal force and external force. So I am going to ask one question, my dear students. Which is the responsible for the body to move? Which is the cause of motion? Which is the cause of motion? So after learning all this balanced and unbalanced force, internal and external force, and then force and effects of force, we can say the cause of motion of body, any body, is external unbalanced force. So we can simply say external unbalanced force can cause the motion of a body. So after learning these all, now we are ready, my dear students. We are ready to discuss, to describe, to explain about laws of motion. To explain about laws of motion. Laws of motion. Now we are ready to explain about laws of motion, my dear students. So these laws of motion are also known as Newtonian laws of motion. Newtonian laws of motion, because there are three laws. There are three laws of motion which are established by Newton, a scientist, Sir Isaac Newton. So now we are going to explain about the first laws of motion. First law of motion. So to establish these laws of motion, my dear students, it took some millions years to establish these laws. It is not in a hurry. They have experimented and resulted and established the law. So there is a huge industry of the scientists who experimented on these laws. Finally, it's Galileo who made the inertia. That is the first law of motion. First law of motion is also known as law of inertia. After that, after the industries of all the scientists on the laws of motion and the moving bodies, so finally it is the Newton who compiled all, who experimented all, who observed all the inventions. Those are those are exerted by other scientists, previous scientists, and then finally it is the Newton who draw the conclusion and who made the laws, these three laws. So the first law is also known as law of inertia. Now we are going to discuss about first law of motion, that is also known as law of inertia. Law of inertia. Law of inertia. This is also known as first law of motion. So first law of motion tells us that if a body at rest, will be at rest. So if a body is moving with a uniform speed in a straight line motion, that will be in uniform motion, that will be in uniform speed in a straight line, unless acted by an external force. So this is what we can say inertia. So that is we have explained in the previous class, in the previous video we have explained, we have learnt. So there is nothing but inertia. That's why this law is known as law of inertia. So if the body will be at rest, it is continuously at rest. So how long will it be at rest? My dear student, think once again. How long, if the body is at rest, how long it will be at rest? unless there is an external force, unless there is an external unbalanced force. If a body is moving in a straight line, so it's clear. The second statement is made by law of inertia is what? If a body is in a uniform motion in a straight line, that will be in a uniform motion in a straight line. How long it will be in a uniform motion in a straight line? Unless acted by an external unbalanced force. So this is somewhat difficult to understand, my students. So this is somewhat difficult. In the previous days, the body which is in motion, if the body has to be in continuous, if the body has to be in uniform motion, there must be one agent, there must be a force, continuous force on the body. Then only it will be in continue. Then only it will be in the uniform motion, uniform speed in a straight line. So previously the people they believed in it statement, but the statement is wrong. The statement is wrong. So the body which is in the uniform motion, uniform speed in a straight line, that will be in uniform motion in a straight line. So until unless there is an external unbalanced force. So this statement is very difficult at that time, my students. So this can be solved by one of the experiment of Galileo. Galileo is the first scientist who makes sense of this statement. If the body is in the uniform motion, that will be in uniform motion unless until there is an external force, external unbalanced force. So by using he has done a series of experiments. Out of there is one experiment out of a series of experiments, my students. So he explained the body which is in uniform motion will be continuously in uniform motion by using some inclined plane experiments. So he has taken two inclined planes like this. It is an inclination, slanting. Inclination means inclined plane means slanting plane. Tilted plane, tilted. It is not straight, it is not perpendicular. It is tilted somewhat like this. So again he has taken another inclination like this. So he observed by dropping the ball from the inclined planes. So here he dropped the ball from here. So what happens, my dear students, if the ball rolled down the inclined plane? Does its speed increase or decrease? Will its speed change? Of course, obviously the speed will change, the velocity will change. So the velocity will change. So is it the velocity, will it increase or decrease if it is dropped from certain height? So obviously the speed of the speed of the ball will increase. The speed of the ball will increase, or the velocity of the ball will increase. Yes. So it is the first situation. The second situation, if the ball is rolling up, when the ball is rolling down, the speed will surely increase. So if the ball rolls upwards, up the inclined plane, tell me, my dear students, will its speed increase or decrease? Obviously its speed decreases. So if there is here the speed decreases, here there is a change in speed by rolling up the object, by rolling up the body. Here speed will change, that is while rolling down the ball from the inclined plane. So in these two situations, there is a change in speed. There is a change in speed, my students. Here change in speed is decreased. Here change in speed is increased. Which means in these two situations, the body, we can say, accelerated. The body accelerated. So in the case, in the first case, the ball increases speed. In the second case, the ball decreases its speed. So let me ask you one question, my students. If the ball is moving in a horizontal plane, what happens? It is the third case. If the body is moving in a horizontal plane, So in case of rolling down, its speed increases. In case of rolling up, its speed decreases. What happens if the ball is rolling on a horizontal plane? Will it increase or decrease? So as it is in between the two cases, so the speed of the ball neither increase nor decrease. Yes, my students, will you getting my idea? Will you coming to my point? So the ball here, the speed will neither increase nor decrease if you roll the ball. Speed of the ball neither decrease nor increase. Then what happens inside here? The ball will move with uniform speed, with constant speed. Speed will be constant here. Speed is constant here. Speed constant. Here, speed decreased. Here, speed increased. So this situation, the third situation is in between first and second situation. So in the first situation, the speed is increased. Second situation, the speed is decreased. In the third situation, because it is in between the two cases, the speed will neither increase or not decrease. So which means the speed will be constant. So these were the second statement of the laws of motion, laws of inertia. First law of inertia, laws of inertia or first law of motion. So if the ball is moving with a constant speed, that will be in a constant speed in a straight line. So how long it will be constant speed in a straight line? Unless until there is an external force. Here there is an external force. So there is an external force. So there is an external force. So this experiment is spoken by, is proved by, this experiment is explained, observed by Galileo and proved to the world. If the body is moving in a uniform motion, if the body is in uniform motion in a straight line, that will be in uniform motion in a straight line unless until there is an external force. So again there is one experiment by students made by Galileo proving that if a body is moving with a constant speed, will be moving with constant speed until and unless there is an external force acted on it. There is an external unbalanced force acted on it. So let us take another example to understand this statement. So for this, my students, the Galileo, same scientist, he has taken two inclinations similarly like this. So he made the ball to roll down this inclination. So what happens, my students? So assume it's a frictionless surface. Assume these inclined planes are frictionless. If there is a friction is an external force. So that will move that will stop the body. That will cause the acceleration. So consider it's a frictionless surface. So here the Galileo, he made to roll the ball on the inclination. So what happens? What did he observe? So the ball will move like this, and the ball reached at the same height. The ball reached at the same height on the other end. So the time here to reach this height, the ball taken t1 time, or we can say the ball attained s1 distance. So what happens if we tilt? What happens if we tilt this inclined towards horizontal like this? So if we roll the ball from here, so the ball will suddenly attain the same height. But here in this case, the body to get the same height, the body take s2 distance. The body travel s2 distance. Here distance is more than first case s1. S2 distance is more than s1. So what happens when we tilt the surface? What happens if we tilt the surface, tilt the inclined plane towards the horizontal more like this? So if you make the fall from this, the ball will roll and it will certainly attain the same height as it was here. So here the ball take S3 distance to reach that height. So what happens, my dear students, if you made this inclined plane horizontal? What happens? Horizontal. So the ball will reach. Will the ball reach at the same height? The ball will reach at the same height. In order to reach its height, it will move. It will move. How much distance it will move? In this case, S3. In this case, S2. In this case, S1. It is moved. It is moved to reach the same height as it was. So in this case, how much distance it will move in order to reach the same height as it was? Because there is no height on the horizontal surface. So in order to achieve the same height, it will continuously move. It will continuously move. So this proves that when a body is moving in a uniform speed, when the body is moving with uniform speed, so in a straight line, that tries to be in the moves with the uniform speed in a straight line, unless there is an external force. Here there is an external force. If there is an external force, it will move up to here. Here also there is an external force. It is move up to here. Here also there is an external force. That's why it is moved up to here, because it's a frictionless surface. So this inclination exert force on the ball. That's why in this case the ball stopped here. The ball in this case stopped here. The ball in this case stopped here. So here there is no external force. Neither the surface has friction, because we have taken frictionless surface. So it is not having friction. Neither there is an inclination to exert force on this ball. So that's why the ball will be continuously motion with uniform speed. So this experiment, let us see this experiment, my dear students, for our better understanding.
We also performed the inclined plane experiment, in which the two frictionless planes were inclined to horizontal table and a ball is pushed from a height by a slide force of hand. The ball rolls down, climbs the another inclined plane and reverses the direction of motion. How far does this ball move up at the another surface? Well, since the slopes of two planes are equal, if we have the look at the height at which the ball has reached, we see the height of both the points is same from the horizontal table level. So, the ball moves to the same height from where it was released. Now, let's decrease the slope of the inclined plane on the right. Release the ball again. What do you see? It has reached the larger distance to reach the original height. Now, what would happen if the slope of inclined plane on the right is eventually reduced to 0? So in this case also you have already seen that the ball has reached a larger distance but has reached the original height. And now, if the slope is eventually reduced to 0 and it is made horizontal, do you know what will happen? The ball will continue to move forever, trying to reach the original height. Now, what would happen if inclined planes are inclined in such a way that h1 is greater than h2? The yellow line here shows the difference in height in these two levels. If a ball is released from this height, it will try to reach its original level. Well, and what happens if there is no inclined plane up to that level? Well, the ball will fly in a parabolic path from the extreme of the another inclined plane. So, make sure when you go to a U-shaped slide in water park, the two levels are equal. Galileo was concerned with how things move, rather than why they move. He showed that experiment rather than the logic is the best test of knowledge. Also, a series of experiments lead us to some basic conclusion. If the slope of surface is downward, the speed of the body will increase. and if the slope is upwards, the speed will decrease. Then, if there is no slope, does speed change? This is what we have just seen from the Galileo's inclined plane experiment. That, if the initial position and final position we see here shown in the diagram, if we decrease the slope, the initial and final position are at the same height from the horizontal level. And if there is no slope on the right side, so, where is the final position?
Students, now we have understood the first law of motion, or that is known as law of inertia. What is that? So when the body, a body continues to any body which is continuous at rest or in the state of uniform motion in a straight line, unless acted by an external force. Simply we can say, if the body which is at rest, it tends to be at rest. If the body is moving with uniform speed in a straight line, it tends to be uniform. It tends to be in a uniform motion with uniform motion in a straight line, unless acted by an external force. So today's homework, my students, define force, write law of inertia. That is the first law of motion. Thank you, my students.